Okay, in case you're feeling fearful of the word induction, essentially what we know is that when things are very electronegative, they tend to pull things towards them, right? And so there's two things that impact whether something gets pulled towards something else. One is this: if you take these two examples here, BrO3 and ClO3, both of these have one oxygen and a hydrogen, right? But then this Br right here is not as electronegative as this Cl. So it's not going to pull. There's not going to be as much induction here as there is here. So this is going to be a stronger acid. Similarly, and this is the O rule. More O's, you end up with stronger acid. That's basically the general rule. So if you take a look at this right here, you're going to see that here we have three things pulling off. One pulling off this direction, one pulling off this direction, one pulling off this, and the Cl in the middle. So you have a lot of pull. Here we have pull here and here, and then also the Cl pulling in this direction. And what I mean by pulling is pulling the electron cloud away, weakening this hydrogen-oxygen bond. So what essentially is happening is it's like fraying a wire. The less tightly held this hydrogen is, the more easily it's going to come off and the stronger the acid is. So like in the first example, if we compare these two right here, because this pulls all the electron density more in this direction, this hydrogen can be easier to pull off than this one is. Similar down here we have a Cl, which is pulling, and another O, which is helping in the pulling, but this is not going to be as frayed as this one right here or this one right here. So our rules are simply this: if you have two things that are identical, whatever one has the greater electronegativity is going to win. And if you have two things that are identical and one has more oxygens, the thing that has more oxygens is going to be more acidic. So let's take a comparison here. And we have HClO and we have HCl2. Identical in every way, but winner, winner, we have an extra oxygen right here. So therefore, of these two, this is going to be more acidic. Now we have H2SO4 and H2SeO4. Now, if you know your general rules, you realize that H2SO4 is a strong acid, so that should be a clue, and H2SeO4 is not. But in reality, what we're looking at here is we're looking at the S and the Se. They both have the same number of oxygens. They both have the same number of hydrogens. The only difference is that sulfur is more electronegative than Se. So what does that mean for us? That means that's the difference in this being a strong acid and this being a weaker acid. And then finally, on this bottom right here, we have H2SO4 and we have H2SO3. And this is comes back to the more O's, more acidic thing. And in this case right here, we know that this is going to be more acidic. Short and sweet. I would review this section. Just remember these two rules right here. If you have a greater electronegativities or if you have more O's, you're going to have stronger acid. In fact, if you look in your textbook, there's a section on structure affecting acidity, and that's this right here. Hopefully this has been helpful.